parallel. So let us do some problem based on those formulas. Okay, so you have been given a capacitor, say of 20 microfarad, and then you have one more capacitor of 5 microfarad. Then you have a 6 microfarad capacitor, and parallel to this you can add 20 microfarad capacitor, and then you have 60 microfarad capacitor. Okay, and this is your terminal A and B. Okay, so you need to calculate C equivalent. So calculating C equivalent. Okay, so you can see here these two capacitors are in series. Okay, so effective capacitance of these two capacitors in series, I can write series capacitor add like a parallel resistance. Okay, so 20 into 5, and this becomes total 25 microfarads. So if you divide by 5, this becomes 5, this is 4. Okay, so now this the equivalent of these two is 4 microfarad. 4 microfarad. Then this 4 microfarad, 6 and 20, they are parallel, so I can add them together. Okay, so if I write, if I take this combination, okay, so this will give me how much total C. So this will give me 4 plus 6 plus 20, this becomes 30 microfarad. Okay, are you getting what I'm doing? So this is, so the sum of these three, okay, this 2 and this 2 are equal to 30 microfarad, and then this equivalent 30 microfarad is in series with this 60 microfarad. So this will give me C equivalent equals to 30 into 60 divided by 90 microfarad. So you go this one. Okay, now you have 3 here, so 10, and you can add 3 here, 1, you can add 2 here. So effective, so equivalent capacitor is become 20 microfarad. Okay, so let me check the answer. So the effective is 20 microfarad. So this way you can use the formula. Okay, you can see what is a capacitor in series. Okay, and series capacitor add like a resistance in parallel. So you can calculate the equivalent capacitor. This is easy. Okay, I'm giving you homework. You please try it. Not much difficult. So you have a capacitor, say this 50 picofarad. Then you have 17. This is microfarad only. 70 microfarad. Okay. Then you have here 820 microfarad, 60 microfarad, and this becomes 120 microfarad. So you need to calculate C equivalent, okay, across these two terminals. So this is your homework. Okay. So 50, 70, 60, 20, and 120 microfarad. So these are, you can calculate equivalent capacitance. Now if more than two capacitors are connected series or parallel, then how can we deal with these capacitors? Okay, so can I erase this one?
Yes, sir.
So now let me solve one problem. We have plus minus 30-volt battery is given. Here we have a 20 millifarad capacitor. Series we have one more 30 millifarad capacitor. Okay, and then here we have been given 40 millifarad. This is, you can connect like this. Okay, and here parallel one more capacitor is 20 millifarad. Okay, so it says find the voltage across each capacitor. Okay, so problem they are asking, find the voltage across each capacitor. Now calculating voltage across each capacitor is pretty simple. So say here voltage is say V1. Okay, say here voltage is V2. Say here voltage is V3. So they are parallel. So voltage will be same. So we need to calculate V1, V2, okay, and V3. Now in order to solve calculate voltages across capacitor, how can we proceed? So when capacitors are in series or parallel, okay, so instead of assuming current, you need to assume that charge is moving in the circuit. Okay, so you need to calculate how much, like you calculate, you have voltage and then you find equivalent resistor and then you calculate equivalent current. Okay, so here you need to find how much total charge is coming flowing in the circuit. So in order to calculate total charge Q, okay, first you need to calculate voltage. So we know Q is equal to CV. Okay, so if I know C of the this assembly or the system, okay, I can find, I have voltage, I can find how much charge is flowing in the circuit. Okay, so let us first calculate C equivalent. So if I want to calculate C equivalent, so C equivalent will be what? These two are in parallel, so I can add them simply. So this become 40 plus 20, 60 millifarad. Okay, and then once they are 60, then these 1, 2, and 3, they are in series. So if I want to add in series, so by one, so series, how can I add? I can add 1 upon C equivalent equals to 1 by 20 plus 1 by 30 plus 40 and 20. How much was there? 60. Okay,
1 by
so 1
60.
by 60. Okay, so now you can solve this thing. So take 60, 1 upon C equivalent. So 60, this become 3, this become 2, and this become 1. So you have 5, 6 upon 60. That is 1 upon 10. So C equivalent is 10 microfarad. Okay. Now you know C equivalent. Okay. So you can calculate Q, total charge Q flowing in the circuit. That will be simply 10 microfarad into how much? 10 microfarad and 30 volts. 30 volts. Okay, 30 volts. So how much is coming? Is coming 300. Okay, into 10 raised to power minus 6, or you can write minus 0.3 millicoulomb. Okay, minus 0.3 millicoulomb. The charge is flowing in the circuit. Minus or plus?
Sir,
These are millifarads. Okay, these are
yes, sir.
millifarads. Sorry. These are millifarads. Okay, so this equivalent will be 10 millifarad. Thank you. Okay, so 10 raised to power minus 3. So this will be 0.3 coulomb. Only 0.3 coulomb charge is moving. Okay, so once I know how much charge is flowing, so charge will flowing like current. You can assume like this current is moving in the circuit. So once you know the charge, you know the capacitor, you know the charge, you can find out what is V1, V1, you can find what is V2. Okay, so let me now calculate V1, V2, and V3. So calculating V1 is very simple. V1 is what? Simply Q charge is flowing and the capacitor C1. So you have 0.3, okay, Coulomb charge, and C1 is 20 millifarad. 20 millifarad. So 20 millifarad means 20 into 10 raised to power minus 3. So how much it become? So it become 20. Okay. How much it become? 66. 6 into 10 raised to power minus 4. Or what I can write? How much I can write in millivolts or volts? Sorry, I need to calculate V1. Okay. So V1 will be Q by C. Q by C1. Okay. So Q is what? Q is 0.3 and C1 is 20 millifarad. 10 raised to power minus 3. So V1 become 3, 200, 10 raised to power minus 3. Okay. And this will become how much? 1.5. This become 10 raised to power 1. Okay. 10 raised to power minus this 2 and minus 3. Minus 1. Minus 1 come here 10. So this become 15 volts. Okay. Similarly, you can calculate other voltages if you want V2. Okay. So V2 will be, Q upon C2. Okay. So Q is 0.3 and that is 30 millifarad. Okay. So if you remove this 300, okay, you have 100. So this become 10 to the power 1, this becomes 10 volts. Okay. V2 is 10 volt. Now what about V3? So in order to calculate V3, I have already calculated the equivalent of these two things. Okay. So what I can do now, I can write equivalent of 60 and 20 was how much? This is 60, total is 60. Okay. So 60, so V3 will be Q upon equivalent of these two, 60 millifarad. Okay. C, what I should write? Say C dash. Okay. So Q equivalent of this two, C dash. So Q is 0.3 and C dash is 60 millifarad. This become 300. Okay. This become 200. So this becomes 0.5 into 10. This is 5 volts. Okay. So now you can count 15, 10, 5, total is 30 volts. So your V3 is your 5 volt. Any question here?
V3 means we have calculated voltage across 40 millifarad or voltage across 20 will be same now.
Both together. I have made equivalent and equivalent capacitor, your charge Q is flowing. So whatever equivalent come through this thing, that will be same. Voltage coming here is same like here.
Yes. Clear.
Okay. So this is in this way we can calculate V1, V2 and V3. Okay. Let me give you one question for homework, and you please try and yeah, बोलिए.
एक बेसिक सा क्वेश्चन है, कैपेसिटर इज द चार्ज स्टोरिंग डिवाइस ना.
Yes.
तो सीरीज में मतलब करंट सेम रहता है, ये समझ में आया, लेकिन यहाँ मतलब चार्ज वो स्टोर ऐसा करके कुछ कम ज्यादा ऐसा नहीं हो रहा है. सब में हमने चार्ज सेम ही लिया है.
भी सबका कैपेसिटेंस अलग अलग है, सब पे वोल्टेज अलग अलग है, तो फाइनली जो चार्ज आ रहा है वो क्या आ रहा है? Q इक्वल टू C1 V1 आ रहा है ना, उसी से हम निकाल रहे हैं ना. फाइनली तो V1 सबका अलग अलग है, सबका C1 अलग अलग है. तो चार्ज कैसे होता है? व्हेन यू अप्लाई वोल्टेज अक्रॉस द कैपेसिटर, ओके, देन चार्ज स्टोर इज Q इक्वल टू CV. I have calculated equivalent charge, okay, total charge flowing in the circuit. So in order to calculate total charge in the circuit, I have proceeded like same we are doing, calculate total current in the circuit. Okay. So total is current and how it is distributing, how it is distributing the voltage. So once you know voltage, you know charge, you know voltage, you know what is the charge of the capacitor. You can find it. You can find it. You can find each capacitor. Now you have each capacitor, you know voltage, Okay, you calculate it and send me. Then we'll see how to describe these things. Okay, you know capacitor of each thing. You know voltage each across each capacitor. Calculate charge. So plus minus. Okay, capacitor is not capacitor. I told you yesterday. Capacitors are basically energy storage device. Okay, it we in rough language we use charge storage. Okay, charge store total charge is always zero, na? Okay, it only maintains the imbalance of charge. In one plate you have plus charge, other place is minus charge. So basically it is an energy storage device E equal to half CV square. Okay,
Okay, sir.
so you can write this plus minus. Okay, this is 150 volt, and then you have a capacitor. Okay, so this is 40 microfarad, and then you have a 20 microfarad. Then again you have 60 microfarad, and then you have 30 microfarad. Okay, so you can find V1. Say this is V1. Say this is V2. Say this is V3. Okay, and this is your V4. Okay, so you need to find V1, V2, V3 in this problem. Okay, so find V1, V2, V3, and V4. Okay, so method is same. You have capacitors. Okay, so you need to calculate equivalent capacitor. Once you know equivalent capacitor, you can find the charge. Okay, so you can find this charge. Now once you find this charge, you can find this voltage, isn't it? Once you know this voltage, you know this voltage, you know this voltage. So automatically now you know, because now here is charge division. So if you know this voltage, you for KVL you can know this voltage. Okay, once you know this voltage, you know the capacitance of this one, so you can calculate how much charge is flowing. Are you getting what I'm saying? Here charge is getting divide, but you don't know the charge division rule. Okay, like current. So what you can do, you find this voltage, you just find this voltage by applying KVL. You can find this voltage. Once you know this voltage, you know capacitor, you can find how much charge is coming here. So total charge is coming here. You can find charge here, remaining charge will flow here in series. Okay, so in this way you can find V1, V2, V3, and V4. Clear? Any question?
Please repeat it too.
So I telling you this is 150 volts given. Okay, you can find equivalent capacitance, you can find total charge. This total charge is moving, is passing through this capacitor, so you can calculate what is V1. So you know this one, you know this one, so by applying KVL you can know what is V2. Okay, once you know the V2 and you also know the charge, so you can calculate how much charge came to this branch. Okay, total charge was Q, suppose Q1 came here, remaining Q2, Q minus Q1 or Q2 will go here, here, and here. So you know charge here, you know volt, you know capacitance here, so you can find V3 and V4 also. Try it. Okay, if not able to do, then I will solve. So this was your capacitor. Okay, now let us discuss inductors. Okay, so circuit symbol for inductor is, okay, put the heading inductor. Okay. So circuit symbol for inductor is So this is your inductor L. Okay. Now say I current is flowing. So this is the air core inductor. This is called air core inductor. I will explain what is the meaning of air core. And then you have one more type of capacitor. Okay. Plus minus V. This is called your iron core capacitor. Iron core inductor. Okay. And then you have one more thing, iron core and variable. Okay. So you have type C. So this say this is A, this is B, and say C. So this say iron core variable inductor. Okay. So in circuit, okay, whenever we are using circuit, we need to take the inductor which is linear. Now, what do you mean by linear? So linear means it inductance should not vary, like we are using resistance. Okay, like capacitor, what we are using, that capacitor should not be variable. So similarly here, your inductor should not be with iron core. Once it is with the iron core or variable capacitor, its inductance L value will change with the applied current or voltage. So that type of inductor we are not going to discuss here. We are only going to discuss inductor which are linear. Okay, air core inductor. So whose inductance value is constant. That's it, you remember. So wherever circuit,
आयरन कोर मीन्स आयरन का बने
iron means you have an inductor, and in inductor you have a iron rod. So once the iron rod is used to maximize the coupling of this flux. Okay. So that with iron core or variable inductor we should not use. Okay, in our linear circuits. So I will be only considering this type of circuit which do not have a iron core. Okay, this is the one thing.
why name air core means
Huh? Air
why
means there is no inductor. Inductor, if you put a iron rod, okay, that inductance that will enhance the inductance. Okay, and that will change with current. So your value is not constant. So those kind of inductor we cannot deal here in linear circuits. So we are only dealing inductor which are constant with time or constant with current and voltage. Okay. So now we know voltage across a capacitor inductor is given by L di upon dt with negative sign, of course. Okay. And if I want the energy stored in a inductor, that is equals to half L I square. Now if you see this V equal to L di upon dt, okay, from here what we can expect, we can see here that if current is constant, okay, if DC condition, okay, if there are DC condition or in DC conditions, your di by dt is 0. Okay, so what will happen, your in the V across inductor will be also 0. That means for DC condition, for DC circuit, your inductor will be replaced by a short circuit, like we have seen that your capacitor behave like a open circuit. So similarly here we can say that your inductor behave like a open circuit. This 1 minute. Okay. So you can write
नीचे वाला सर पोर्शन में विजिबल नहीं है, का नीचे वाला पोर्शन नहीं दिखाई।
हाँ, अभी लिख ओके, अब ये दिख तो रहा है, यहीं तक ही है, बस यहीं तक ही है, v equals to 0 तक ही है, v equals to 0 दिख रहा है,
यस सर यस,
यहीं तक ही है. Okay, so you can write now,
so it behave like an open circuit, na?
short circuit. So for DC circuit, your inductor behaves like inductor behaves like a short circuit. Okay, short circuit means the voltage across inductor will be 0. Okay, now I know what is V equals to L di by dt. Okay, so if I want to find the current, so current will be what, 1 by L V dt. Okay, so if I want to calculate total current, so similar to capacitor, inductor also has a memory. Okay, so I can put the limit minus infinite to time t v dt, because if there is already current flowing in the circuit, okay, at t is equal to 0, so that current should add when I if I further improve increasing the current. Okay, that current also we have to consider how much current is flowing before we starting flowing the current in the inductor. So now if I solve this one, I this will give me what, this will give me 1 by L. Okay, so minus infinite to 0 v dt. Okay, not visible. If I write now here, okay, so break this limit like we have done yesterday, 1 by L minus infinite to 0 v dt plus 0 to t v dt. Okay, so your I will become 1 by L. Okay, now this is v dt, so minus infinite to 0. So what I can do, v equals to L di by dt, L di by dt, and dt here, so plus 0 to t v dt. Okay, I am putting the value of v for inductor, v equals to L di upon dt. So this dt will cancel. Okay, so if I solve this one, so this will give me L will also cancel, so this become I. Okay, a function of time, limit time is minus infinite to 0, and this will be equals to 1 by L 0 to t v dt. Okay, so now if I write the formula for this one, so what I can write, I can write I equals to 1 by L 0 to t v dt plus I at t is equal to minus infinite will be 0. So you can write here I, okay, I at 0 time minus I at minus infinite time. So you can put 1 upon L 0 to t v dt. Okay, and this will be simply I naught. Okay, I naught means I at t is equal to 0, this becomes 0. So this is your formula for current. Okay,
सर
so हाँ
सर एक छोटा सा डाउट है सर, इंटीग्रल में माइनस
हाँ हाँ बोलिए।
मतलब सर टाइम माइनस इंफिनिटी टू टी
पहले कल भी तो किया था, माइनस इन्फिनिटी मतलब जब हम करंट फ्लो करना शुरू कर रहे हैं उससे प्रीवियस टाइम। ओके, व्हेन वी आर स्टार्टिंग एनी एक्सपेरिमेंट or when we are applying any current through this inductor, or we are applying voltage, before that if there is any current present or not, that also we need to take care. Okay, that means this is a memory element. Give me 1 minute. Minus infinity means before time before t is equal to 0. Okay,
ओके सर
so let me see how we can deal inductor in circuit. Okay, so let us solve one problem. suppose we have been given a voltage source, say this is 12 volt, okay, and here we have a 1 ohm resistance, okay. Then we have here 4 ohm resistance, okay. Here we have one capacitor of 1 farad, okay, and then we have here a resistance of 5 ohm, okay, and then we have here inductor, say of 2 Henry. So in this question they are asking, okay, under DC condition, under DC conditions, okay, find A. You have to find what is I flowing through this. You have to find IL. Okay, you have to find total current I, this I. Okay, then you need to find VC, voltage across capacitor, and you need to find IL. Okay, and number 2 you have to find B, energy stored in capacitor and energy stored in inductors. Okay. So let us solve the problem. So under DC condition, when you apply DC, so this capacitor will become open, isn't it? So let me make this capacitor open. So capacitor is 1 farad. Okay, I'm making it open. And what should I do with this inductor? What should I do with it? Short circuit? Okay, so in DC condition, your inductor becomes short circuit. Okay, this is 2 Henry. This becomes short circuit. Okay, short circuit means now it has a zero resistance. Okay, now I want to find out what is the voltage here. Okay, and what is the current. So let me find first total current. Total current will be what? Okay, once I short, this becomes 0. Okay, so this becomes 1 ohm, 5 ohm. There are total 6 ohm resistance. Okay, so this current is going here. This is open, so no current will flow here. The same current will come here, and the same current will come here. So I can write my I will be equals to IL. Okay, but this current is coming from here. Here there is an open, so no current is going here. So all the current through this node is coming again here. So I equal to IL, and that is equal to what? 12 upon 6 ohm, and that is become your 2 ampere current. So I know I equal to IL equals to 2 ampere. Okay. Now what about VC? How can I calculate VC? I know this 2 ampere current. Okay. I know this 12 volt, 2 ampere current flowing here. So drop will be here. Well, how much? 2 volts. 2 volts. So 12 is there. 2 is here. Remaining 10 will come in this branch. So in this branch there is no current. So no loss is here. So whatever voltage is here, the same voltage is here. So I can find here your across capacitor VC will be how much? 10 volt. So I can write my VC is equals to 10 volt. Okay. So I know VC, I know IL. Okay. Now I can find what is WC and WL. Calculate.
5 ohm के अक्रॉस भी करंट जा रहा है ना, तो उसका कंट्रीब्यूशन भी हमें VC फाइंड आउट करके लेने पड़ेगा ना.
भी हम तो ये इस लूप में KVL लगा रहे हैं. 12 volt is coming here. Okay.
Yes.
How much we are spending here? Remaining coming here. So whatever coming here, that is equal to my VC.
Clear.
Okay. So this is 10 volt. So you can calculate VC. VC is what? VC is equal to half CV square. And I know what is half. This is the 1 farad. Okay. And V is 500. V square is 100. So this become 50. So this become 50 joule. Okay. And similarly, I can calculate omega L. Omega L is half L I square. Okay. So if I write this is 1, okay, L was 2 Henry, I was again 2 ampere, 2 to become 4. This is 1. Okay. So this is 4 joule. So yeah, as you can see, these are very easy circuits. So we are not going in detail. Okay. I just want that you should be familiar with this inductor and capacitors, because when we'll solve this operational amplifier, okay, so there sometimes they will include this inductor and capacitor. So in under DC condition, how we can play with these things. So you should have some little bit idea to deal this inductor and this capacitor. We are going detailed network analysis. Okay, so DC condition, your inductor is your short circuit and your capacitor is open circuit. Just do little bit practice on these inductor and capacitor. That will be enough for enough for this course. Okay, so so I'm giving you one more problem, okay, as a homework. Say this is 10 ampere current is flowing, okay, and this is your resistance 6 ohm, and then you have an inductor 6 Henry, okay, and you have this 2 ohm resistance here, and you have this 4 farad 4 farad capacitor, okay. Across this, the voltage is VC, okay. So you need to find what is VC, what is IL, okay, and WC and WL.
सर करंट सोर्स कितना लिखा है सर?
10 ampere, sorry, this is 10 ampere, this is 10 ampere. Okay, so just I will take 5 minutes more, just how to deal inductors when they are in series and in parallel. So let me derive the formula for C equivalent. Okay, it is pretty simple. So just 2 classes are more remaining for network analysis. Okay, after that we start our regular course, the semiconductor, then diode, then transistor, then op-amp. Okay, just 2 more classes are there for this, how to deal with this L, C in the circuit. So probably from Monday we'll start our semiconductor physics. So if inductors are in series, so if inductors in series, how can we deal with inductor in series? Suppose we have, say, inductor L1, inductor L2, okay, and we have inductor Ln, and they are connected with a source V, Vt. So now I want to, so I know the voltage will be here V1, V2, V3, and Vn. Okay, so I can write Vt, okay, will be V1 plus V2 plus V3 plus Vn. Okay, and I know that V1 is equals to nothing L1 di upon dt. Okay, so whatever source we are applying, that is giving same change in current. Okay, di by dt is same within the circuit. So L2 di upon dt plus L3 di upon dt, okay, plus Ln di upon dt. Okay. So if I take common, this will be L1 plus L2 plus L3 ln di upon dt. Okay, and you can write this is a L equivalent. This is your L equivalent. Okay, so you can draw equivalent circuit or you can write equation. So Vt will be your L equivalent d upon dt. Okay, that means your inductor add like resistors in series. So this will be L1 plus L2 plus L3 plus Ln. Similarly, you can calculate when inductors are in parallel. Okay. So when inductors are in connected in parallel, so inductors in parallel circuits. So shall I erase this one? Let me
Yes, sir.
solve for inductors in parallel. So suppose we have these inductors connected in parallel. Okay, okay, this is L1, say L2, say L3, and Ln, and say a voltage Vt is applied. Okay, Vt or say current source is there. Okay. So say Vt. V function of t. So a current is coming, okay, here in the circuit, and that current has to divide time as a function of time. Okay, this will be I1, this will be I2, this will be I3. So let me take DC source, this time DC source. Okay, this is a DC source, plus minus V, I3, and say this is IN. So my I will be what? I will be I1 plus I2 plus I3 plus IN. Now how can I write I? How can I write I? Anyone? How should I write I? Okay, so I have
Integration form.
integration form you can write. Okay, if you know any other form, we can write other form also. Okay, so let me write with integration form. So I1 will be what? 1 upon L1 V dt, and then I1 at t is equals to 0. Okay, similarly this will be 1 upon 0 to 1 by L2 0 to t V dt plus I2 at t is equals to 0. Okay, and so on, 1 upon ln 0 to t b dt plus I n at t is equals to 0. Okay, now let's simplify this one. I have this I, okay, 1 upon L1 plus 1 upon L2 plus 1 upon L3 plus 1 upon ln, okay, 0 to t v dt, okay. And if I sum this all the things, it will be total current I at t is equals to 0, okay, where I at t is equals to 0 is equals to I1 at t is equals to 0 plus I2 at t is equals to 0, and so on In at t is equals to 0. So if I solve this further, okay, I can write I is equals to, this is 1 upon L equivalent 0 to t v dt, and total current I at t is equals to 0 time, and 1 upon L equivalent is equals to 1 upon L1 plus 1 upon so on like ln. So it's like the same like your resistance. So we are pretty much at the end of this network analysis. So probably a one and a half class, okay, more, and I will give some questions for practice, okay, and then we'll proceed for semiconductor physics. So semiconductor physics itself will take 5 to 6 classes, and once semiconductor is finished, then we can start our diode, transistor, and op-amp, and after that we will start digital electronics. Okay. So any question? Any question from today's class?
No, sir.
Anyone? Any question? Okay. So if there is no question, okay, we can stop. If any questions there, I am waiting to reply. And thank you. Good night. Okay.
Okay, sir.
Thank you.
Thank you, sir. Good night, sir.